Hello and welcome to another video. In this video we're going to be continuing on with the Typescript line 75 and we're going to be doing course schedule. So in this problem there's a total of num courses that you have to take from 0 to num courses minus 1. You're given an array of prerequisites where prerequisites I means you have to take course B before you take course A. For example, 0, 1 means you have to take course 1 before you take course 0. Return true if you can finish all the courses, otherwise return false. So in this example here, 0 is a prereq for 1, so you can take course 0 and then you can take course 1. And in this example, both courses are a prereq for each other. So 1's a prereq for 0 and 0 is a prereq for 1. So if you think about it, if you just take like a normal college schedule, right? When you plan out a schedule, you pretty much need to take courses that you've satisfied all the prereqs for. And so when you plan out your schedule, you want to take all the courses that you satisfied all the prereqs for, and then later on you want to take the courses that those prereqs are no longer a requirement for because you'd have taken it. So let's kind of go through an example. And what I'm going to do is I'm going to draw courses as nodes, and then I'm going to draw an edge from a course to another course, and that's going to signify that that course is a prereq for another course. So we could do this for this one here, right? Just for the 0, 1. So let's, for this very simple example, here, course 0 is a prereq for 1. So any course that has no edges coming into it means you can take it whenever you want. And they don't ask you like to finish all your courses in some set amount of time. They ask you just if it's possible or not. So you don't have to optimize which courses you take. You just have to make sure that you can take them all. So any course that has no edge coming into it doesn't have any prereqs, so that's allowed to be taken. So in this case, you'd be able to take course 0. And then what happens is anytime you take a course, whenever it has edges coming out of it, that means that course is a prereq for those other courses. But when you have taken it, it's no longer a prereq because you've satisfied that prereq. So now we can take course 1 and we've essentially traversed the whole graph. So let's look for another example. And this is the other example that they gave us where it's like this, where the courses are prereq for each other. And now the problem is, in order to take a course, you have to have taken all the prereqs for it, which means there have to be no edges going into it. So here there are no nodes here that have no edges going into it, right? There is nothing. So we can't like traverse this graph. So let's look for something bigger. Let's say we have course 0 and it's a prereq for course 1 and it's a prereq for course 2 and maybe course 2 is a prereq for course 3 and course 2 is a prereq for course 1 and course 1 is a prereq for course 5, something like this, right? So let's see what this would look like essentially. So essentially, remember, we can take any course that has no prereqs to start off, right? So we can take course 0 because it has no edges coming into it. The number of edges coming into it is 0. So we can take course 0, then we would get rid of all the courses that that's a prereq for, so we're going to get rid of this. Now we're going to see, is there any other course with no prereqs? It looks like course 2, right? So we can take course 2, and then we would get rid of all the edges coming out of course 2. And now you could see that like this is doable, right? We can take course 3, then we could take course 1, this edge would disappear, and then we could take this course. So this is traversable and this is doable, but let's try to find a way where it's not doable, essentially. So maybe like, let's just say, let's try something like this maybe, and see if this is doable. So course 5 is also a prereq for course 2. Let's see what happens here, right? So now, when we take course 0, we would get rid of all the edges. And now, is there a course with no edges going into it? Well, course 1 has edges, course 5 has edges, course 3 has edges, and course 2 has edges. So essentially, as you're traversing, whenever you get to a state like this, where everything, if you just count up the number of edges coming into it, right? So this would have 1 edge, this would have 1 edge, this would have 1 edge, and this would have 1 edge. So there is no course with 0 edges coming into it. So this is undoable. So essentially what we have to keep track of a few things, right? And this is how we're going to use to represent this graph. One, we're going to, for every node, keep a list of edges, or keep a list of nodes that that node is a prereq for, right? Because that way, when we go through a node, when we take that node, we can just go through this list and get rid of all these prereqs. So it's important to know that. And then the other thing we need one more thing. Actually, we need 2 more things. But so we need for every node, keep a list, not a list, a count of prereqs needed for it. right? So for every single node, we're actually going to keep account of the prereqs needed for it. And as we go through the prereq, we can just go through this list of nodes that it's a prereq for and decrease the counts of all of them by 1. And then whenever the count is 0, that means we can actually put it into our valid our valid courses that we can take. And then we need one more thing, and this can be any data structure you want. I think in some solutions they use a queue, but this can be a stack. This can be use a queue. The word doesn't matter here. So we're just going to have an array of all courses currently available to take. Okay, there we go. And let's actually go back to our previous example. So instead of having this like impossible thing, let's go back to our previous example where we have 0 and it's a prereq for 1, and let's kind of show what this would look like essentially. So we have 0, it's a prereq for 2, let's say, and a prereq for 1. So now let's actually draw out our dependencies here, right? Our list of edges and our stack and everything. So for the one thing, we need to keep a list of nodes that node is a prereq for, right? So for 0, it's a prereq for 1 and 2. For 1, it's a prereq for 5. For 2, it's a prereq for 1 and 3. For 3, it's a prereq for nothing. So 3 would just have an empty list here. And then, I mean, you don't really, yeah, I guess it's fine. You can add into this. And for 5, you would have an empty list as well, right? So something like this. I think that's pretty correct. Okay, now remember, we're going to have a list for every single index of how many prereqs it has. So let's draw out our indices. So this is going to be index 0. I guess I did notice this 5 should be a 4, so let's change that as well, right? So let's make this a 4. Let's get rid of this, and let's make this a 4 as well. Now let's use this. So we have 0, we have index 1, 2, 3, and 4. And then we're actually going to write the values here. So for 0, there are no prereqs, right? There are no edges going into it. So that's going to be 0. For 1, there are 2 edges going into it. So that's going to be 2. For 2, there's 1 edge. For 3, there's 1 edge. And for 4, there's 1 edge. Okay. So now we need to create a stack or just an array. So we'll call that like S or something. And it's going to be a list of nodes that have no prereqs because those are the nodes available to take. So once we go through this, we're going to say, okay, node 0 has no prereqs. So we're going to put that in. Then essentially what we are going to do is we are going to keep traversing till the stack is empty. And every time we traverse a node, we're just going to like count up that we traversed, right? So we'll have some kind of count. It's going to be like 0. And then every time we traverse a node saying like, hey, we actually like took this class, then we'll add to the count. And then once our stack no longer has anything, we'll just see like how many courses did we take. And if it was every course, then we will return true. So let's kind of walk through how this goes. So essentially what's going to happen here is we are going to take out 0, right? Let's actually maybe, actually this is fine. So we're going to take out 0, right, out of here. And we're going to add 1 to the count. And then for 0's neighbors, we're going to say, okay, every node that 0 is a prereq for, let's decrement this count. So 0 is a prereq for 1, so we are going to decrement this count now because we just took one of the prereqs, right? So it has 1 less prereq. And 0 is a prereq for 2, so let's decrement that count. But whenever you actually have a node that you just made, the number of courses needed to take 0, that means this node is now available to take. So when we decrease 2 to 0, we're going to say, okay, 2 is 0, so now 2 is available to take, so we're going to add 2 to this array. So we traversed all of the nodes in 0. We made them, we decreased their prereqs, which essentially in the graph is the same as doing this, right? We just took 0. It's the same representation. So now we will, and then we added the count. So now for 2, we're going to take 2 out. We're going to add 1 more to the count. So actually just get rid of this, update the count to 2. And here, we're going to take 2 out, right? We're going to take 2 out. And we're going to go through the list for 2 now. So for 2, the edges are 1 and 3. So we're going to decrease the count for 1. It is 0. And now we can say, okay, 1's available to take, so we'll add that to the stack. And 3, we're also going to decrease it, and 3 is also now available to take. So we went through both of those, right, and we got rid of 2, and that's the same thing as just getting rid of 2 here and getting rid of this edge. So we can take 1 or 3 now. And now let's say we take out 1. And then, like I said, the order doesn't really matter. I think we are going to end up popping from the end, but the order doesn't really matter. So I guess let's take out 3 first, because we're going to end up popping from the end. But you can use a Q, it's the same thing. So we're going to take out 3. We're going to increase the count to 3 here. And we're going to go through its list of edges. It doesn't have any. So we're done with 3. Now we are going to take out 1. And we are going to increase the count. And we are going to go through its list of edges, so 5. This should be 4, actually, right? Yeah. Because we changed 5 to a 4, so it should be 4. So we went through it, and we're going to decrease it by 1, right? So let's decrease it by 1. So now this 4 is available to take. And notice how whenever we do these, we don't even have to keep track of a visited set, because essentially a value will only go to 0 one time. Like if a value goes to 0, whenever you traverse a node, you will never have that node in its dependencies again. So we're essentially treating this as a visited set. We don't have to keep track of a visited set because a value will only go from 1 to 0 one time. Like once it's 0, you will never find it in another list that you're traversing. So we went through 1. Now we have one more node, that's 4, right? So for 4, we are going to go through its list of nodes, and there are none. We're going to increase this count to 5. Whoops. We're going to increase this count to 5, and we don't have any more nodes because there is no nodes for 4. There are no nodes for 4. So now we're done with the stack, and simply when we're done with the stack, we went through every single course that was possible to take. And then we just check, like, is this number the same number as like our total courses? And if it is, then we have a success. But sometimes you're going to have some courses, like I said earlier, you know, that you'll have some loop like this. And then what's going to pretty much happen for something like this is, let's say you have like 2 here, and you take 2, right? You take 2, you would decrease your 1, but 1 is still not available to take here. Like 1 would still have an in degree of 1. And then you would just never be able to put in the stack, and you'd be done, and your count here would be like 1. But then you have 4 courses total. So that's the solution when you have a loop. It'll just not add anything to the stack. And then as soon as you're done with the stack, you just check for the count. But that's pretty much it. So let's recap. We need to, for every node, keep a list of nodes that node is a prereq for, and that's pretty easy. We can just go through our edges and do that, right? Because it's like child parent. So for every parent, we're just going to add the child to its list of edges. And then for every node, keep a count of prereqs needed for it. So that is also simple, right? Every time your node is a child, you will just add 1 to it. And then you will have an array of all courses currently available to take. That's also pretty easy. Essentially, what's going to happen is once you make this list and you make this, you just go through this in degrees and you just say, okay, for every node that has a prereq of 0, I'm going to add it to my stack because that's available right away. And then you just traverse your stack, pop nodes individually, go through its list of like courses that it's a prereq for, update it, add it to the stack, and so on, and update this variable. And that's pretty much it, and it's called a const topological sort. Definitely recommend to learn that one. It's a little bit more advanced of a graph algorithm. And it's not super common, so it's definitely one that, you know, you can definitely do a lot of stuff before this one, but good to know. So let's actually code it up now. So let's full screen. So we're going to need a couple things, right? We're going to need this prereqs hash map, essentially. And so it's going to be a record, and the type is going to be of type number, and then it's going to be a list of nodes that it's connected to, so it's going to be a number right here, and it's going to be empty for now. Then we have our in degrees array. It's going to be new array, length num courses, and we're going to fill it with 0 initially, and we'll just increase it later on. So now we need to loop through all our prereqs, so we can just say for let rec equals 0, rec is less than prerequisites dot length rec plus. And we are going to destructure here. So we're going to say constant child parent equals the prerequisite prerequisites rec. And there we go. And essentially now that we have the child and the parent, it's pretty straightforward, right? We're just going to push the child into the list for the parent. So prereqs parent equals prereq. We want to make sure, first of all, that so in an object, like this key might not exist. So we're going to check for it existing first, right? So the way to do that is you can actually do prereqs parent question mark. And then what will happen here is if it does exist, it will be the left one. And if it doesn't exist, we'll take the right one. So if this key does not exist, we're going to make an empty list. Otherwise, we're going to take whatever we had before. And then finally, we need to actually add the child to it. So prereqs parent push child. And we're going to increment the in degree count for the child, right? Because it has one more prereq for it now. So there we go. So now we populated our in degrees and we populated our object with all our prereqs. Now we're going to make our stack, like I said, or we can call that whatever we want, but I'll just call it stack. And it's going to be a number array, and we're going to make it an empty array at first. And then we need to loop through our in degrees and check for every single in degree that's 0. So we could say let degree equals 0. Degree is less than in degrees length. Degree plus plus. Misspelled. And essentially, we're just going to check if it's 0, then we can push it in, right? So if not in degrees degree, meaning is it 0, same thing. Or you could say if it's 0, then we need to add it to the stack. Stack.push degree. Okay. And what I'm going to do, instead of making a new variable for, but you could do this in whatever way you want, instead of making a new variable to count the courses we completed, we're just going to decrement num courses every time we complete a course, and then we can just check for it being equal to 0 afterwards. So we're going to say while, so we need to basically say while stack actually exists, so while stack.length is non-zero, we're going to make a parent. So const parent equals stack.pop. Then essentially we are going to decrement our num courses because we just taken one. We're going to increment the in degrees for the parent, right? Actually, do we need to do that? I don't think we need to do this. Yeah, definitely not. We don't need to integrate. We don't need to decrement the in degrees for the parent. We only need to decrement the in degrees for the child. So yeah, so this is fine. And now we are going to check if it actually has prereqs. So if not prereqs parent, we can just continue. Because if you try to like get the length of this object and it doesn't exist, then it's going to give you an error. So you want to check if it exists first. So if there are no prereqs, let's just continue. Otherwise, let's loop through all the prereqs. So for let child equals 0, child is less than prereqs parent length child plus plus, right? So we iterate through every children and we decrease their in degrees. So we want to get the child index, right, essentially. So we're going to do that. So we're going to say, because we don't want to use like super long, like prereqs parent child or something. So we can just get a child index equals prereqs parent child. And now we need to decrement that in degrees. And now we need to actually check, is our child index, is our in degrees child index 0? And if it is, that means this course is now available to take, right, as I showed you in the picture. So if we go back, if something drops to 0, like from 1 to 0, we need to know that and we need to add that into the stack. So that's what we need to do here. So we can just say if not, same thing as here, essentially. We can copy most of this. If not in degrees, child this time though, then we can just push it, and this is going to be child index. Okay, and then finally, when we're done with this loop, now we just simply have to check what's our number of courses, and if we did it correctly, then our number of courses left to take should be 0. So now we can just return num courses equals 0. And that would essentially return true if we have nothing left to take, and it would return false if we do have courses left to take. So let's see how many errors we have. Looks like it's fine. Let's see here. Yeah. Okay, let's submit. Okay, so you can see it's reasonably efficient. And let's talk about the time and space for this one. So it's going to be like, these are definitely annoying to get the time and the space for, so let's think about it, I guess. So first thing, we are looping through all of the prereqs, right? So that's going to be time-wise, you know, whatever the length of the prereqs is. So that's going to be like, let's just call that P or something. So we're looping through all the prereqs. Okay. And then what else are we doing? We're pretty much just pushing it. So this is all going to be like O of 1, like this whole thing is O of 1. We also did make in degrees. So in degrees is going to be like length of the number of courses. So you can definitely have like 50 courses, right? And only like one prereq. So they are going to be different, so you are going to need to add them. So it's going to be prereqs. Let's call this maybe prereqs or something. Let's call this courses. And let's keep going, right? So to make this in degrees, it's the number, this num courses thing. Okay. So this part is going to be faster than in degree. So now we have to figure out how long this stack section takes. So essentially, you can add a course and remove a, you can add a course and remove a course once. So that's going to be like O of courses. But what are we actually doing, right? So it looks like we can add a course and remove a course once. But for every course, we have to actually go through its edges, right? So I believe that's going to be essentially worst case scenario. We are going through like all the prereq edges pretty much. So that would be like length of prereqs, I think, because for every time there's a new prereq, there's a new edge. So essentially, worst case scenario, you would go through every single edge. Yeah. So this thing would, in total, for this entire while loop, go through every single edge, worst case, which would be O of prereqs again. And yeah, I think when you add and remove from the stack, that's going to be O of prereqs. Sorry, it's going to be O of courses, right? Because every course you can at most add once and remove once. That's going to be like courses times 2. And then, like I said, for all of these, all of the edges combined will be this prereqs, right? That's going to be how many edges you have. So I think it's something like this for the prereqs and the courses. And so yeah, it would be like 2,000 plus 5,000 or something, worst case. Yeah. Now for the space. So let's think about that one. So essentially, worst case scenario, I guess once again, we can use the prereqs technically, because prereqs is going to be good. So for every prereq, there's an edge. And for every edge that's in an array. So I think that's going to be also kind of similar, because you have to store the key and the value. So essentially it would be like every course and every prereq. So I think when in our adjacency list or, you know, hash map for our edges, that would be the same thing, because essentially you would have every course as a key, and then every prereq would be in some list, and the length of all the lists combined is going to be prereqs, pretty sure. And then as far as the in degrees, that's going to be length of num courses, so that's smaller. And as far as a stack, that's also going to be length of num courses, so that's smaller. Yeah, so I think they're both this. Someone can definitely correct me if I'm wrong, but I think that does sound right to me. But yeah, these kinds of problems and like Dijkstra's algorithm are definitely tricky. Like most graph problems with vertices and edges are definitely tricky to get exact time and space for, because there's a lot going on. There's like 2 or 3 things, so you're gonna have to figure it out. So definitely could be wrong on this, but it sounds pretty reasonable to me. But yeah, I think this is correct. So yeah, I think we're gonna call it here. And so if you did like this video, and if you did like this video, please like the video and subscribe to the channel. It helps grow it a lot. And I will see you in the next one. Thanks for watching.